A mysterious interstellar object is on a collision course with Earth, and scientists don't know what it is. The first known interstellar object in our solar system. In 2017, scientists discovered the first known interstellar object in our solar system. Meet Oumuamua, which means scout in Hawaiian. According to NASA, this cigar-shaped object is around 400 meters, 1,312 feet, long. It was discovered as it was slingshotting around the Sun at over 87.3 kilometers per second, 54.2 miles per second. The verdict is still out on what Oumuamua is. It could be a comet, asteroid, or maybe something else. One leading theory is that it's a hydrogen iceberg. That's because scientists observed Oumuamua accelerating away from the Sun, instead of floating toward it. It's as if this interstellar object had a little jetpack blasting it further into space. But if it blasted its way into Earth's atmosphere, would it trigger a deadly chemical reaction? How was the interstellar object Oumuamua formed? If Oumuamua was solid hydrogen ice, it would have been formed in extremely cold conditions. Hydrogen sublimates, or turns from solid to gas, at a frigid -267 degrees Celsius, -449 degrees Fahrenheit. And because empty regions of space average out at a temperature of -270 degrees Celsius, -458 degrees Fahrenheit, it makes sense that this object could maintain its solid hydrogen structure. As it rounded our Sun, that ice on the surface of Oumuamua would vaporize. And that would create the vaporous jets propelling the object straight at you. Just like a rocket. This would also explain why Oumuamua has such a strange shape. It was heated by the Sun, and it became smaller and thinner like a used bar of soap. But while empty space may be frigid, the temperature around the sunny side of the Earth could get as hot as 121 degrees Celsius, 250 degrees Fahrenheit. This means our interstellar guest would continue to diminish in size as it traveled closer and closer to Earth. And that wouldn't be the hottest temperature Oumuamua would experience. Like other meteors that enter our atmosphere, it would heat up to a scorching 1,648 degrees Celsius, 3,000 degrees Fahrenheit. It would just melt before it could ever reach the surface. For this space iceberg to make a devastating impact on the ground, it would need to be massive. But that doesn't mean you'd be entirely safe from catastrophe. The real danger of this scenario, why is molecular hydrogen so dangerous? Is something much, much smaller. Molecular hydrogen. Hydrogen is known as an indirect greenhouse gas. This makes it different than gases like carbon dioxide or methane. Greenhouse gases trap heat directly. Our atmosphere currently contains about 0.00005% molecular hydrogen. And if a hydrogen iceberg vaporized inside of it, this could accelerate the effects of global warming. As soon as hydrogen filled the atmosphere, it would react with hydroxyl radicals. These molecules are produced by water vapor, ozone and sunlight. And they typically react with gases like methane, helping to reduce its concentration in the atmosphere. If Oumuamua released a lot more hydrogen into our atmosphere, the methane concentration would increase as well. And methane is 25 times more potent as a heat-trapping gas than carbon dioxide.